Hi everyone and welcome to this video. To start with, sorry about the condition of my hands, but I've been trying to clean a rusty old chain with vinegar just as an experiment to see if it works, and it does work. Anyway, that's a different thing. So this video is about solar. Now this is the Modbus board, which I've shown you before. It's got a Max 485 chip and also an Arduino Pro Mini, and the idea of this is that it basically communicates with a charge controller, and I've got a Solar Tracer 4215BN. I don't know if anyone's familiar with that model, but that's what I've got, and this can basically communicate with it. So this and this together can communicate with the charge controller and get some interesting details back, like voltage and charge amperage and whatever, various other different things. And this can also communicate with the ESP32 and therefore giving it details. So that's what that board does. This board here, this is the, let's put it the right way around, this is the switch control board as I've labelled it there. And this board here is in charge of turning a relay on or off, and the relay therefore controls the inverter. And I've also got these two here, and these two control the contactors, and that decides which will be powering. I mean, will mains be powering the system or will solar be powering the system? So that's what this board does here. You can see the flyback diode and a few other different bits and pieces. But I've not shown you the main board, and I'm going to show you now. And finally, this is the main board. So this is the controller board, and this is very kindly produced for me by PCB GoGo. And as you can see, these three boards all need revisions already. I've already made mistakes and things, so I'll need to have this board redone at some point. But on here you can see that it's got a little controller, which in fact this controller is broken. One of the keys doesn't work in it. I don't know why, but it doesn't. You can see the pull-up resistors, the ESP32 itself, and actually there's a capacitor in there. There's a buzzer. There's the ADS115, which is a, well, I'm using it as a current shunt sensor. It's actually just an amplifier, a PGA, programmable gain amplifier, and of course ADC is analog to digital converter. Various LEDs which indicate different things, and there's an area for the light sensor there. Power here, there's a switch. This is where the current shunt feeds in. And I've also got these here, which I've broken them off for the time being. These go to the auxiliary boards, which I've already shown you, which is the Modbus board and the power control board. So yeah, I got this made, I designed it, got it made by PCB GoGo. Now, if I just show you here, there's a little display, and now it's going to be quite awkward. I'll have to put this down actually. So you can see solar, charge, drain, battery, light, AI is on or off. Now I can actually control this. I can go down, turn it off, but the actual enter key or select key doesn't work. It's because of this little keypad here. It just doesn't work for some reason. So source, inverter, etc. The date and time, the IP address. But yeah, this is designed to communicate with my server, and there are also two apps that I've created. There's a Windows app and there's an Android app, and I can actually show you me controlling this with those apps. Now what I want to do in one of my next videos is show you the apps and also wire these up with it. These need some adjustment. I mean, even though these work here, I've actually switched the collector and the emitter. Now I don't know how I've done that, but I have. So in this particular example here, these two still work, but the new revision has those switched over. Now in here, controlling the relay, they need to be working properly, they need to be switched properly. So for whatever reason, I've put the load on the emitter side. No, I don't know why I've done that, but it needs to be on the collector side. So I've revised this board and I've got to get it remade, and I've got to remake it. Other than that, this board's good to go. So I plugged the contactors in there and plugged the inverter in here, or the inverter switch in here, and that will work perfectly. Now this board also needs a revision, only a minor revision though. This one needs a termination resistor between ground and ground, charge controller ground to this ground, and that's because for whatever reason the ground of the charge controller is higher than the ground of this. Now again, I don't know why, but what I found is if I just simply put a termination resistor on the ground, then it just reduces off any I can't remember the word, but like voltage that's parasitic voltage. It can get rid of it, so I need to have a resistor put on there. Now I've actually revised both of these boards already. I could probably show you the revisions, but that's what I need to do on those two boards anyway. On this board, now I can't remember all of the changes on this one. There weren't many, but one obvious one is that you can see here that the I2C bus is reversed, and again, that's a very bad mistake, but I've linked SDA to all of the SCLs and SCLs to all the SDAs, which is very bad, but as you can see, those need to be crossed over. So I've fixed that in the new version. And I think there were one or two other changes as well, which I can't really remember, but generally speaking, I think it's to do with minimising the board. So you see all the resistors here, I've put them in there underneath the controller so I can, make the board smaller. So that's where we are with solar. Now, it's been quite a nice summer really, and it would have been nice if I could have had this in place, but it's just not worked. I've just not had time to do it. I've had that many other things to do. But yeah, so far so good. I'm going to submit the revisions to a PCB creation company, and I'll have the new ones here soon. And then hopefully I can put it back online again and show you all. Anyway, that's that for this video. Let's put all these in the scene and you can see.